Hi everyone. Today's topic is the Unit 6, Day 3, Day 4, hold on, Day 4 video notes on complex numbers. So in order to understand the importance of complex numbers, we need to kind of understand how numbers are organized. So when we first learned about math, you counted using natural numbers. They start with 1 and they're all the whole numbers, no fractions, no decimals. As we continued, we learned that 0 was a number. That's our set of whole numbers. It's not included in this Venn diagram. But then we learned as we continued that we also had negative numbers, and that's what we call our integers, our set of positive and negative whole numbers, including 0. And then we learned that we have numbers in between those whole numbers, fractions and decimals. These are rationals, things like 1/3 or 0.27 or I don't know, pretty much anything you can think of. We have irrational numbers as well, which are included in the set of real numbers that are not rational. These numbers are numbers that cannot be expressed as a fraction, like pi, or when you take the square root of something that's not a perfect square, like the square root of 2. You get a decimal that doesn't terminate, and there's no pattern that that we can see, no discernible pattern. So anytime you take the square root of a number that's not a perfect square, or anything with a radical that doesn't simplify perfectly, that would become an irrational number. And then we have the set of imaginary numbers. Imaginary numbers occur when we try to take the square root of a negative number, something that can't be done. And then all of these numbers together, the reals and the imaginaries combined, give us what we call complex numbers. So now that you're started in Algebra 2 and now that you're in advanced math, we're going to solve not just for our real solutions, which is what we had always done in the past, but now we're going to include imaginary. So we're going to ask you to find what's called all complex solutions. So just a quick reminder, imaginary numbers exist when we try to take the square root of a negative. We represent it with the lowercase letter I. It becomes useful when we run across an equation that we couldn't solve before, like x squared plus 1. Now we can solve it because we have opened up our solutions to include not just the real numbers, but also the imaginary numbers. This should be a review. What's interesting about imaginary numbers is that it kind of cycles every fourth exponent. So we start with I, and then if we multiply I by itself, I squared, we get -1. If we multiply by I again, we take that -1, or we raise I to the third power, we get -I. And if we raise it to the fourth power, we end up with -I times I, which would be -I squared, or -1 times a negative, which gets us back to +1 again. So what happens is, like I said, we kind of get this pattern over and over again. So once we hit I to the 5th, it's the same as I. So if you had to simplify I to any exponent, you would just need to break it into its exponent that is a factor of 4, and then times whatever it's left over, and then just simplify that leftover part, because anything to the 4th power or to a multiple of 4 is going to simplify to 1. This is also something that can be done in the graphing calculator as well. Okay, so now let's talk specifically. That was a review of imaginary numbers. Now we're going to talk about when we combine real and imaginary numbers together. We call that, like I said, a complex number. So when we write them, we typically write the real part first and the imaginary part second. And we're going to treat the imaginary part as if it's really just like a variable. So when we add them, it's really just like combining like terms. You add the real part and you add the imaginary part, and you keep them separate. When we multiply them, again, we multiply them as if they were a variable. a complex number is a binomial because of our real plus our imaginary piece. So when we multiply them, we use binomial multiplication, we distribute, or FOIL is what we hear a lot. The difference is that when you end up with this I squared term, you have to make sure that you simplify that, because remember that I squared is the same as -1, and so we can replace the I squared with a -1, and then it becomes a whole number. I'm sorry, not a whole number, a real number again, and then we can combine it with our real number in front. Conjugates are an important concept when we talk about imaginary numbers, just as they were when we talked about square roots. A conjugate occurs when we have an opposite sign on our square root, or in this case, on our imaginary piece of our number. So, for example, if we have 5 minus 3i, the conjugate of it would be 5 plus 3i. So the real number is exactly the same. It's the imaginary piece that is the opposite sign. Why is this important? Well, because when we divide with complex numbers, we are not allowed to have an imaginary number in our denominator. Similarly, we were not allowed to have a radical in our denominator. So to get rid of that, we need to multiply the top and the bottom of our fraction by the conjugate. So we're going to be doing a lot of practice with that. We're going to talk about how imaginary and irrational solutions always occur in conjugate pairs. The reason being for that is whenever we create a square root or an imaginary piece, we get it by taking the square root. And when we take the square root, we always take the positive and the negative root. And so that's always going to give us two possible solutions whenever we do that. So when we get a square root answer, what we call an irrational answer, it's going to come in conjugate pairs, as well as all of our complex solutions will come in conjugate pairs. So we'll keep that in mind. That's going to be important moving forward with our unit. So please, thank you for watching, first of all. I really appreciate that. Please come in next class with any questions that you have, and we will look at how we'll apply these concepts in math problems this unit. And if you did watch to the end, I appreciate that. You will get extra credit if you take a picture of the notes that you've taken throughout the video and email them to me. Okay? And I'll see you guys in class. Thank you. Bye-bye.